Greetings. Welcome to the Dr. J Vlog series. It's Monday, February 17th, 2025. Today we're talking about mathematics and statistics. Last Monday, I hope to show you that those of you who claim to hate math or think you're terrible at math and all that sort of thing, that you're still nonetheless mathematicians. You are everyday mathematicians. You're using maths, as they say in England, throughout your daily routines. You are dealing with everything from household budgets to cooking and calorie regulation to determining the shortest travel routes to calculating living space and curtain lengths, to say nothing of the many ways in which math enters into your work and your professional lives. So here's something else you probably didn't know or realize about yourself. You're also a statistician. You are using statistics on a regular basis, even if you haven't had any formal training in the field. You're constantly analyzing the world around you to evaluate, for example, what's normal. Think of the normal distribution in statistics, which I'll talk a little bit about. What's to be expected. Think in terms of probability or odds ratios in statistics. How things are related to one another. That's what we mean by statistical correlations, for example. And how to evaluate the interrelationships among several factors that might lead to certain outcomes. And that's where you can think statistically in terms of multiple regression or multivariate analyses in general. Point being, you're far more sophisticated, perhaps than you ever realized. You might even have some secret designs or models in your head or in your private journal, perhaps, about how you expect the world to unfold. In fact, you might even be a statistical savant or a genius, analogous to the Scarecrow, if you will, in The Wizard of Oz. What do I mean by that? Well, recall how the Scarecrow famously sings in The Wizard of Oz about I could while away the hours, conferring with the flowers, consulting with the rain, and my head I'd be scratching while my thoughts are busy hatching, if I only had a brain. Well, the supposedly brainless Scarecrow is plagued by this crushing self-doubt, having convinced himself that he lacks intelligence. And yet, who ends up being perhaps the most consistent and reliable group strategist? The Scarecrow, who deduces many clever solutions to the challenges that Dorothy and her comrades encounter en route to Oz. So, Dorothy, did her best to reassure the Scarecrow that he was actually quite smart. But the final affirmation came from the great Wizard of Oz, who stated the following: "Why, anybody can have a brain. That's a very mediocre commodity. Every pusillanimous creature that crawls on the earth or slinks through slimy seas has a brain. Back where I come from, we have universities, seats of great learning where men go to become great thinkers. And when they come out, they think deep thoughts with no more brains than you have. But they have one thing you haven't got, a diploma." And so, of course, the great wizard grants the Scarecrow an honorary PhD, which he describes as a Doctor of Thinkology. So if you're watching this particular vlog, I'd confer upon you a Doctor of Thinkology, apropos of your chosen field of expertise. Make no mistake, you are a Doctor of Thinkology in at least one and perhaps several areas. But you might not have thought about yourself in regard to mathematics and statistics. You might think, well, that's not me, though. That's not where I have any expertise or any special skills. And so my job is to convince you otherwise. First, what do you already know about statistics? Again, besides thinking perhaps that you don't really like statistics. Well, for one thing, you know all about recurring patterns in nature, in your lives, and something that we refer to as normal distributions. What's a normal distribution? Well, it's simply the array of values associated with a given distribution of something that can be measured, something that varies. In normal distributions, we expect that most values will bunch up around the mean or the average, and then there are going to be some extreme values that become less and less common the further away they are from the center of the distribution. It's also known as the bell curve, after the famous telephone inventor Alexander Graham Bell. Not. Rather, it's actually referred to the bell curve because of the shape of the distribution, that beautiful bell shape that appears on a graph or on your computer screen. They're actually known as Gaussian distributions, named after Karl Gauss. He's the German mathematician who first described the mathematics of the bell curve. And so bell curves they produce for us something called the central limit theory, or the central limit tendency, which is to say the frequency of the different scores that cluster around the center of this distribution of a graph tend to be relatively consistent in the sense that the mean, or the average, and the median and the mode, these are different statistical properties, all align at exactly the center point or in the peak of that bell curve. So I'll show that and talk about it more at a later time, but I don't want to get into the mathematical details so much today. Okay? I'll just mention that there are indeed countless examples of potential bell curve distributions that we could examine. And so in that sense, we all have lots of information about normal distributions or average scores and average occurrences of different kinds of events and that sort of thing. I'll talk in the future specifically about something such as IQ, which some of you may know if you've heard about IQs or studied them to any degree. Again, there are different IQ tests, but one of the most conventional ones pegs the average IQ in the general population at about 100. More importantly, in terms of the statistical properties of the bell curve, we know that about 2/3 or just over 2/3 of the population, or the scores on a given distribution, will lie within a certain fixed range of the center of that distribution, something called the standard deviation. Again, I'm not going to get into that today, but the point being that we know that there's this tight clustering around the center of the distribution. And then as you move further and further away, if you're, for example, really high on an IQ or really low on an IQ score, then you're going to lie at the tail ends of that distribution. You're going to be something called an outlier. So again, I'm going to not get into the math today. Normally I would use a PowerPoint or graphs, that sort of thing. I don't have that available, given where I am right now. So anyway, the point is that once you realize that there are these countless patterns out there, then you can use that brain of yours, and you frequently do, to estimate probabilities or the likelihood of events occurring. You quite often informally assess probabilities, where everything from the likelihood of rain falling in a given afternoon, or deciding whether to take your umbrella or not, to the chances of whether your preferred team is likely to win the upcoming game, to if you're a gambler, you'd want to know that information for sure. But beyond that, you want to be able to get a sense of almost anything whereby you're trying to predict the future or future outcome or future state of affairs. But, there's an unlimited gamut of issues where we have to make such judgment calls. Doesn't mean that we're right all the time, but that's because we don't always have all the relevant information, or what we sometimes call perfect information. And so that leads to my next point, that you are quite adept at using information to identify possible linkages between causes and effects, to identify possible correlations. Again, even if you haven't done or don't know anything about formal mathematics and how we calculate correlations, you almost certainly have identified a number of important correlations that have helped you navigate your lives successfully. For example, you already know that if the best player on your team or the best players are hurt, then the odds of your team winning the next game decline, perhaps significantly, depending on how important they are to the team. If you show up late for work, you probably know in advance the outcomes for that type of transgression. Conversely, If you're employed and under contract and you show up to work regularly, there's almost 100% probability that you'll be paid on a regular basis, depending on your employer. If you're speeding more than 20 clicks above the posted speed limit and you pass a speed trap, there's a high probability that you'll be stopped and ticketed by the police. And if you consume too many alcoholic beverages, you're almost certain to become inebriated. And depending on how hammered you get, you might expect a greater chance of suffering a hangover the next day. So all of these events and countless others are based on our common sense understandings of basic correlations. That said, we can't say with 100% certainty that each outcome will definitely occur, but rather we typically guess with a high degree of probability what will happen, what we expect to happen. And that leads to my final point. The more information that we have, and if it's directly relevant to the issue at hand, all of this would enhance our ability to establish not only correlations, but to predict the likelihood of complex events unfolding. So again, that requires a solid understanding of the different factors or influences at play that help shape specific outcomes. And so in that sense, we're often, as the saying goes, weighing our options. The more thoughtful we are in that regard, generally the better off we are in terms of making good decisions. And that's exactly what we do with statistics. We look at the different factors, plunk them into different types of statistical models, and then render our decisions about which factors have a significant effect and how strong an effect each of the different factors has in terms of creating a particular outcome that we're interested in. So, for example, again, to the whole sports issue, or if you're into gambling or betting on sports games, you'd not only like to know which teams are playing, obviously, but what's the current state of their rosters? Are they missing any key players, or are there any injuries? How much rest have the players had on each team? Have they been traveling? Who's the home team? Who are the visitors? What are their relative strengths and weaknesses on both offense and defense? And so on. So in short, you can't guarantee a specific outcome or result, but you can weigh all of the factors that you know of and make a more informed decision. And that's the exact right phrasing, the informed decision. We can and usually should be making decisions based on the informedness, based on the information available. We do that on a routine basis and often with rather mundane events, rooted in our knowledge of the different factors at play and our understanding of their relevant influences. We routinely model, for example, the key considerations that affect how likely we are to show up to work on time. If there's a winter storm, we know that we have to factor that into our decision making and maybe wake up earlier, maybe shovel the driveway, that sort of thing. If our car's in the shop or the bus isn't operating, then again, we'll have to take that into account, factor that into the equation. If we expect there to be a higher volume of traffic, or we're traveling at an off hour, or conversely, if we're traveling on the weekends, then these are factors to be considered as well. Okay? So you have enough brain power to figure out so much just using logic, math, and statistical information, even if you don't define what you're doing in these terms. And so in future vlogs, my hope is to help build upon your mathematical and statistical capabilities, teach you more about some of the key aspects that you can use on a regular or daily basis, and then use that knowledge and your skills to enhance your ability to make more informed decisions. So hopefully today's vlog has served as a bit of an inspiration to jumpstart that process. And so to that end, perhaps you'll continue down this particular journey and this pathway toward greater practical usages and broad wisdom that comes from continuing to develop your analytic abilities. Until next time, may you and yours continue to create peace in your hearts and nurture love throughout your lives. We'll see you next time.